Okay, let's see now two problems for heat pumps. زين who will read the question? عمر again. زين.
Determine the COP of a heat pump that supplies energy to a house at a rate of 8,000 kilojoule per hour for each kilowatt of electric power it draws.
Okay, so we are dealing with a heat pump, and heat pump it deals again with two reservoirs, and it takes from the cold reservoir. Okay, takes QL, and so this is a heat pump, and deliver the heat to the hot reservoir, and that's QH. And to do that, it will need input power. So this is power and that's power. Okay, and here we are given that supplies energy to a house. So this is the house. Okay, this is a heat pump, and this is the outside. So it supplies to the house. QH equals 8,000 kilojoule per hour for each kilowatt. So for each kilowatt, WN, 1 kilowatt. Because per 1 kilowatt, it will supply 8,000 kilojoule per hour. So we need the COP, or or also this is called gamma. For heat engine, COP of a for heat pump, or gamma, and detail. Okay, زين كمل عمر.
Also, determine the rate of energy absorption from the outdoor air.
Okay, so also we need what the energy absorption from the outdoor. So from outdoor, this is QL. Okay, so we need that. Okay, this is again straightforward. The COP or gamma of the heat pump equals the desired, which is QH for heat pump, divided by WN. We need to put this both in 1 unit, so we'll convert this. So we multiply this by hour, and this is 3600. Okay, 60 times 60, and that will give us 2.22 kilowatt. Okay, so this one is 2.22 divided by 1, because we have 1 there, the power n. So this is 2.22. Okay, the other thing that we need QL, Q.L, and that's again, if we apply here the energy equation, the first thermodynamic equation is that heat in equal heat out. So QL plus WN equal QH. So QL equals QH minus WN. Okay, so that is 2.22 minus 1.22 kilowatts. And if you want to convert this into kilojoule per hour, so we'll multiply by 3,600 seconds per hour, and that, if you do it, then you will get 4,400 kilojoule per hour. Okay, So that's the solution for this problem. The second problem. So again, من بيقرأ السؤال شباب؟ مرة ثانية يا عمر، ما شاء الله عليك. يلا.
A heat pump is used to maintain a house at a constant temperature of 23 Celsius. The house is losing heat to the outside air through the walls and the windows at a rate of 85,000 kilojoule per hour.
Okay, so the house loses heat by this amount. So there is heat loss through the wall and the windows. Okay.
While the energy generated within the house from people, lights, and appliances amounts to 4,000 kilojoule per hour.
Okay, so also the people inside, they will generate. Okay, every one of us, we emit heat. Okay, depends. There are standard values for human being. Okay, depending on the gender and the activity and so on. So this 4,000 kilojoule per hour is from the people and from the appliances, TV and other electrical appliances. Okay, so these are input heat that will be generated.
For
Yeah.
a COP of 3.2, determine the required power input to the heat pump.
Okay. So we have this, that we have Q out is 85,000 kilojoule per hour. We have Q, let's call it Qn, 4,000 kilojoule per hour. Okay, this what will be input to the house. Okay, we have COP or gamma of the heat pump as 3.2. Now we need the power input, so we need to know what is the value. N. Okay. So these two. So if we take the house as our control volume, there is heat input from the people and the appliances, heat output there, and we'll have also heat input from the heat pump. This heat input from the heat pump, and this will be QH. Okay, so the conservation of mass says that in energy in equal energy out. So QH, okay, plus 4,000 equals out 8,500. 85,000. Okay, so this is, I mean, we need heat in equal heat out so that the temperature will be constant. Okay, whatever temperature it is. Okay, for the temperature to be constant, there must be heat balance, heat in equal heat out. Therefore, so from this, we found QH equals 85,000 minus 4,000, that is 81,000 kilojoule per hour. Okay, so now we know QH, we know COP, so or gamma. So gamma, this is heat pump, so it equals QH divided by the value N. Okay, so from this, the value N equals QH divided by gamma, and QH, so this one, 81,000 divided by gamma, 3.2, that will give us 25312.5 kilojoule per hour. Okay, hopefully this is the right number. Okay, if you went in kilowatt, then we divide by 3,600, and that will give us 7 0.03 kilowatt. Okay, divide this by times 1 over 3 600. This will give us this, and that's the final answer. Okay, thank you.